Hi everyone, and welcome back to our channel, PHYS.
Here we teach you everything you need to know about PHYS 102 and how it's all around us.
We're the Whizzes, so let's get started.
Reporting live from Royal Victoria Hospital, where a 20-year-old was just brought in after being struck by lightning.
Charge to 200. Clear.
And brought back to life.
Some crazy stuff. Today's video, we will focus on electric potential and storing charge, which can both be seen in the news report we just watched. Let's look at some general information on these topics to help you understand. First, let's recap from chapter 16 on what electric field is. Electric field is a physical field that surrounds electrically charged particles and objects that exerts force on all other charged particles and objects in the field, either attracting or repelling them. So that brings us to what electrical potential is. Electric potential is the energy that is needed to move a charge against an electric field, and a charge in an electric field feels an electric force, so work can be done on it. It then has the ability to gain or lose kinetic energy that it converts from or into electric potential energy. Now let's talk about capacitance. Capacitance is the ability of a component or circuit to collect and store energy in the form of an electric charge. It is dependent on voltage and charge, which we can see in the equation here of C equals Q over V. Capacitors are energy storing devices that store the electrical potential energy in the electric field of the separated charges. It consists of two metal plates with an insulator between them, which we'll see in this diagram here. All right. Now that we know some basic information, let's go to Molly and Maya for some fun PHYS facts and see how this relates to the news we just watched.
Lightning arises when there is a large amount of electrical potential discharge formed in the cloud. As we learned from last week, charges are transferred when things rub together. So during a thunderstorm, the clouds come into contact with each other and rip out electrons from the air, causing the positive charges to stay towards the top and the negative charges to move towards the bottom layer. The Earth, by induction, draws the negative charge on the bottom layer of the clouds, resulting in a high electric field capacitor. The large imbalance of charges then results in an electrical discharge, which we know as lightning. And this happens over a brief period of time between the bottom layer of the clouds and the Earth, or between cloud and cloud. Bolts of lightning have a lot of volts of electricity, which can be too much for your body to handle in the unfortunate case that you get struck. This high amount of electrical activity causes your heart to stop and go into cardiac arrest, which makes you go from this to this.
So an automated external defibrillator, aka an AED, is a type of capacitor that sends an electric pulse or shock to the heart to restore a normal heartbeat when someone is experiencing cardiac arrest. That means their heart has suddenly stopped beating and their breathing has stopped. So a capacitor, as we already talked about, has two metal conducting plates that have an insulator between them called a dielectric. These are the two plates and this is the dielectric. The dielectric stops the electrons from flowing just between the plates, since they're both conductors, and instead it creates a circuit around this way. The material also determines the amount of energy that a capacitor can store when voltage is applied. So most defibrillators are energy-based, meaning that the device charges a capacitor to a selected voltage and then delivers that prescribed amount of energy in joules. Essentially, you take it and charge it with a battery inside, which creates potential difference and stores some charge on them. And then, when they make contact with the patient, it creates a second circuit where the charge from the plates funnel through the heart with the objective to interrupt and hopefully resuscitate the electrical impulses. The voltage applied to a patient depends on the presence of the heartbeat, its strength, and pace, so how slow or fast it is. In this scenario, our victim had no heartbeat at all, so she needed 200 joules.
Now that we know everything about lightning and defibrillators, here's some solutions on how to avoid getting struck by lightning. So some things that you can do during a thunderstorm are stay inside, avoid being in water like a pool or the lake, and avoid areas with big trees.
Thank you for joining us this week on PHYS.
We hope you learned something and see you next week.